Okay, so let's look at problem 1 here. See, we're looking at the difference between two outlet stores, looking at delivery times. We want to know, is there a difference between the two? That tells us we're going to have a two-tailed test, and of course it's two population means. We'll go ahead and note that alpha is 0.1 and we have 99% confidence. We'll need those later in the problem. And then in this case, the sample size, sample mean, and sample standard deviations are given for both stores A and B. So I think before I start working any of the things on here, I want to go ahead and find out right away if this is going to be a test with the pooled variance or the unpooled variance. So this is S. I need the variance S squared. And this is 5.76, just 2.4 squared, and 9.61. Since neither of those is more than twice the other, we will pool. And that tells us, A, our degrees of freedom is going to equal NA plus NB minus 2. And that's 20 plus 20 minus 2 is equal to 38. And it tells us we're going to use the following formula to calculate the standard error. I think I'll do this down at the bottom. I'll erase it before we move on and work the other parts of the problem. So this is get the standard error for the sampling distribution of the difference between two sample means. All of this is just a subscript. That just tells you what the statistic is in this problem. Since the parameter is the difference between two population means, the statistic is the difference between two sample means. There's no other numerical meaning. That's just a subscript to tell you what the sampling distribution is. So for the pooled, the formula is S squared A NA minus 1 plus S squared B NB, that's an N, B minus 1 divided by NA plus NB minus 2. All of that by 1 over NA plus 1 over NB. And that's equal to, I'm going to put it up here, the square root of 5.76 times 19 plus 9.61 times 19. All that divided by 38, that's NA plus NB minus 2. And all of that, once you have that, multiplied by the square root of 1 over 20 plus 1 over 20. And that comes out to be 0.877. So that's just saying the standard error is 0.877. So anyway, before I worked anything out, I determined whether or not we need to pool. I looked at the two variances. Neither was twice the other, so I pooled. And I went ahead right away and said for the pooled, here's the formula for degrees of freedom, and I calculated it. And also, here's the formula for standard error, and I calculated it. Okay, so now, let me go ahead and first right over here that the degrees of freedom was 38, and the standard error was 0.877. So for question A, comment on the sample size. First of all, what you want to do is look at the smaller of the two sample sizes. In this case, they're both the same, so we're looking at 20. Well, that is greater than or equal to 15, which means skew is acceptable. It's okay. But if outliers or extreme values are present or expected in the population, this analysis that we're going to do is, let's say, questionable. If those are true, you should base your analysis on larger sample sizes. So write the research and null hypothesis. This is part B. Mu, remember we said it's based on difference, mu A not equal to mu B, and HO, mu A equal to mu B, or equivalently, mu A minus mu B is equal to 0. I think this first formulation is probably a little more on the face of it, or when you first do it, a little more understandable. But this second one is useful when you come to answering, when you come to graphing the sampling distribution, because the center of that sampling distribution will be 0. Okay, so moving on to part C, we're going to use the critical value approach, which is going to say reject the null hypothesis if t-test is greater than some value or less than negative. That's because we have a two-tailed test here. And if you look up for two-tailed test in alpha 01 and 38 degrees of freedom, you should see 2.712. So then we'll compute the t-test. As the statistic, x bar A minus x bar B, minus the hypothesized parameter, mu A minus mu B, hypothesized. That's mu A minus mu B, hypothesized there, divided by the standard error. So we have 36.9 minus 35.7 divided by 0.877. And I'm going to go ahead and just note here that the top of that is 1.2 divided by 0.877. It's kind of nice to think of that as one number. We're really looking at the difference between the two sample means, which is 1.2. And so I think you'll find that useful at some points. At some point, I certainly do. That comes out to be 1.37. That is not greater than 2.712. That is not less than minus 2.712. Therefore, you fail to reject HO and conclude mu A could equal mu B. So when we reject HO, when we fail to reject HO, we don't say that HO is true, we only say that it could be true. I think the idea of that will become a little bit clearer when we get down to the confidence interval. But for now, just keep in mind when we fail to reject HO, we don't say that mu A is equal to mu B, we just say that it's plausible. You could think of it this way too, that whatever difference between the statistic we have, the 1.2, and a difference of 0, whatever difference there is there, could be due to sampling error and not due to a real difference between population means. Up and give us a little more space. Okay, so moving down to part D, the sampling distribution. And first of all, when you compute the p-value, you need to use the stat function on your calculator to obtain the p-value. To do that, and I'll have a little handout in a separate place that you can look at this, but you'll do stat, tests, to-samp, t-test, and then you'll just fill in the values on that screen and go down and hit calculate, making sure that you hit not equal to when you get down to the greater than, less than, or not equal to, and that when it asks you for pooling, that you say yes, because we are using the pooled variance in this problem. Well, anyway, if you do that, you will get a p-value of 0.179. So draw that here. Make sure you label the axis with the appropriate, in this case, the appropriate statistic. This is the sampling distribution of the difference between the two sample means. The center of this, mu A minus mu B, is equal to 0. That's why I rewrote the null hypothesis in the form of mu A minus mu B is equal to 0. That just helps you out with getting what is the number at the center of that distribution. Now, the specific value of x bar A minus x bar B that was observed in this sample was 1.2. Again, think of that as one number. It was 36.9 minus 35.7, but it's down here. So also, when we're looking at the p-value in a two-tailed test, remember this was a two-tailed test, that means that the p-value really encompasses area in both tails of the distribution. So that p-value of 1.79, half of that 179 is in each tail of the distribution. So that takes care of part T, just getting the stat, using the stat function on your calculator to obtain the p-value and to draw and label the sampling distribution. In part E, the first part says test the hypothesis using the p-value. So we're going to reject HO if p-value is less than the level of significance or less than alpha, which in this case is 0.01. Of course, the p-value we have of 0.179 is not less than 0.01, so you will fail to reject HO and conclude mu A could equal mu B. Of course, this part of the answer is going to be the same when you do the critical value approach, when you do the p-value approach, and when you do the confidence interval approach. There are advantages and disadvantages of each of those three approaches, but they're all going to end up with the same final statistical decision here, and the same conclusion here. I should say they will, as long as you use the same alpha or a consistent confidence level, which I will endeavor to do in the problems that we have in this class. If you look through some other stat books, you'll find that not everyone does that. They'll, for example, use an alpha of 0.01 and then have a confidence interval that's 80% or 90%. And of course, since you're changing those, you would or could get different answers here. But I'll try to keep those consistent. I just think that it's a little clearer as we go through if I do that. Okay, so on part 2, it says to give me an if-then statement that summarizes what the p-value means. And basically what I'm doing is just taking this sampling distribution and rewriting it in the form of a sentence. If mu A minus mu B is equal to 0. I could have just put if mu A is equal to mu B. Those are equivalent statements. If they are equal, then the difference between them is 0. So either one of those will do fine. So you can think of it back to this way. If HO was true, then there is a 0.179, a p-value chance of observing or obtaining, however you want to think of that, either x bar A minus x bar B greater than or equal to 1.2, or x bar A minus x bar B less than or equal to this point right here. And what this point is, or has to be, is the same distance from the center of the distribution as this value. And since the center is 0, this has got to be 1.2, minus 1.2. So that takes care of part D and part E. The picture of the sampling distribution is part D, and then E is here and here. Okay, now part F, which is our confidence interval. Now let's remember that our confidence interval is always the statistic plus or minus the confidence coefficient times the standard error. And so we have x bar A minus x bar B plus or minus t times the standard error. And that is 1.2 plus or minus 2.712. Make sure you get this number from the table. That's for 99% confidence in the t table, times the standard error, which was 0.877. So that's minus 1.18 to positive 3.58. That interval, or the main thing you need to know about that, or recognize about that interval, is that it includes the number 0, which means mu A minus mu B could equal 0. Now this might be the good place, or I think it is a good place to say, when we fail to reject HO, we only can conclude that HO could be true, in this case that mu A minus mu B could be 0, because obviously it could be minus 1.18. Could be 3.58 or anything in between there. So it could be 0 because 0 is in the interval, but obviously it could be other numbers as well. It could be, by our reckoning, somewhere between minus 1.18 and 3.58.